Well, class, our today's lecture is about mechanics. Mechanics is the paper 4 of A levels. Okay, so this is paper 4. It is carrying 50 marks, and time given will be 1 hour 15 minutes. Okay, and the questions which are going to come are from 6 to 8 questions will be coming in this paper. Okay, either 6, 7, or 8. Okay, um, this category questions like this many questions will be coming here. Okay, all right. Okay, our next question is next thing is we are going to discuss the chapters. What kind of chapters are we going to discuss in it? Our first chapter will be forces and equilibrium. Forces and equilibrium. Second chapter will be kinematics in straight line. In straight line. Momentum. Newton's law of motion. And this last but not least is work, power, and energy. All right. In our first chapter, we are going to discuss about forces. Okay, so what is a force? A push or a pull. A push or a pull is called force. And its unit is Newton, which is named after the name of Sir Isaac Newton. And its formula is F equals to ma, where F is force, m is mass, and A is acceleration. Okay. So types of forces. Now forces are of two types. One is contact force, and another one is non-contact. So whenever there is a contact force, it means a surface is involved. So where surface is involved, tension. In case of tension, surface is always involved. Okay, or a body is involved, friction, normal reaction. Okay, and for the sake of non-contact, weight. It is weight, or gravitational force is always also known as non-contact force, and another one is magnetic force. But we are not going to discuss magnetic force over here right now. Okay, we will be discussing only these four forces because tension can be considered as upward force. So I will tell you everything about this now later. Okay, so we will be discussing these forces. So right now I'm going to tell you about weight. What is weight? Weight is basically a force experienced by a body or a push. Okay, a force experienced by a body experienced by a body due to gravity. Due to gravity. And its unit is going to be, as it is a force, so its unit will be Newton, and its formula is going to be F equals to mg. Okay, here the value of g will always be 10 meter per second square. You don't have to consider 9.8. If you will be considering 9.8, examiner is going to deduct your marks. Okay, and there are a few things which a few myths which I will be let you to change that from today's onward. Like from today's onward, you are going to change those myths. Okay, so before that, we are going to discuss about equilibrium as well. As you can see that equilibrium before like in O levels, you have discussed two laws. First law of equilibrium and second law of equilibrium. So first law says that sum of all forces are equals to 0. Same way, sum of all moments or a torque is equal to 0. This is moments. Okay, sum of all moments are equal to 0. Sum of all forces are equal to 0. So when it says sum of all forces, it means that whenever a body is at equilibrium or at rest, more than one force is going to act. Okay, at rest or equilibrium, more than one force will be acting, and we will be discussing these cases as well. Okay, so let me tell you about that. We are going to consider now, let's say, I'm having a body, a box which is resting on a table. Okay, if it is resting on a level ground or a table, it means that forces will be acting on it. One will be upward and another one it will be downward. Left force, right force. Okay, these four forces will be acting. Upward force, up, down, downward force, right force, and left force. Okay, if my body is moving in this direction, then this will be my forward force. To compensate that, there will be a backward force, which will be frictional force, Fs, and upward force. Usually we consider either tension as upward force or normal reaction. Okay, normal reaction like R. If there is a string attached to this box, then there will be tension. If there is no string, then that will be a normal reaction. Okay, and for downward force, we assumed before that, like we always assume, like in O levels, we always assume as weight. Okay, as a downward force. So it becomes a myth for the students, like they always consider downward force as a weight. But this myth is gonna change, or this myth is gonna destroy your whole M1 if you are gonna consider the same downward force as weight. Okay, because shapes are gonna change, so our perspective will be changed. So how are we gonna assume weight? As you know that weight always acts from the center of the body to the ground. Okay, it always acting from the center of the body. So for now, we are gonna see the different aspects like this. If you are having this one, you can say that if you are having this one, then our perspective will be changed. And for this one, our perspective will be changed as well. And for this shape, our perspective will be different because look, this is a ring which is attached to the string, and it is on a road as well. Okay, and for this perspective, our perspective is going to change, our rules will be changed. So what are we going to do? We are going to make some rules. We are going to introduce a person P, okay, over here, because we have to change a reference point. We are going to change our reference point so that we can solve these kind of questions easily. Okay, so to make my reference point, I'm going to introduce a person P. So there will be rule for the person P. Rules for person P. I'm going to introduce that person P. Rule number one, person P will always be standing at the contact point of the surface. Person P will always be standing at the contact point of the surfaces, 90° with the surface. That person 90 degrees to the surface. Okay, these are the two rules. And third rule, there will be one more. Upward force will always be coming out from its head. Upward force will always be coming out from its head. Okay, these rules show that we are now going to introduce a person P, okay, on these graphs. So see, suppose that this one, I'm going to introduce my person P. Look, it's according to rule number one, it always be at the contact point of the surfaces. This is the contact point, okay, and it will be making an angle of 90 degrees. It means that this one is going to make an angle of 90 degree with the surface, okay. So in this way, I'm going to draw my person P. And upward force will always be coming out from its head. It means that if this is my upward force, then this will be my downward force. It is rightward and left force, okay. So other three forces will be chosen accordingly. Is it clear? Now, next thing, which is very important. If this is my upward force, it was a horizontal curve, horizontal plane. Okay. If we are choosing our person P on a plane, horizontal plane, then this is the pattern, this is the criteria. And here we are going to consider weight as a downward force. and rightward force will be forward force, and left force will be frictional force, and upward force can be tension or a reaction, normal reaction. Okay, but if we change the scenario, if I'm going to change the scenario like this, like inclined plane or this, then what are we going to do? Here we will be making another rule for that, because we know that our person P knows only these four forces, except that he does not know any other force. Okay, so if we are having a force like this, which is a slant force, then how are we supposed to know that? Like how our person P, like our person P will be get to know about this force. Okay, so what are we gonna do? Now we are gonna first draw person P at the angle of 90 degrees to the surface. This is my person P, okay? And normal upward force is gonna coming out from its head. Downward force will be in this direction. This will be my left force, and there will be my right force. Okay, these are the forces which I have drawn and which I told you as well. Downward. This is my right force. This is my left force. Okay, but that person P does not know this force. So what am I going to do? I am going to resolve this component into a rectangular components, because I know that person P can know only vertical or horizontal forces. So I will resolve this into these forces, rectangular components. Okay, so you can see that. Let me just remove this. As I know that my person P knows only up and down forces, so I will be resolving it. This one is 25 Newton. So this is my theta. And in front of that, it will always be 25 sine theta. And this will be 25 cos of theta. Okay. Now let me tell you something about the resolution of vectors as well, so that you should not be confused about resolution of vectors. Suppose that we are having two forces. That is my force, which is at inclined, or which is a slant force. Okay, if this is my slant force and it is called F, as we know that our person P does not know this force, so we are going to resolve it into its rectangular components. Okay, rectangular components, we are going to draw one horizontal line, and that one is imaginary. That's why we will be resolving it into its like dotted line. Okay, we are not supposed to draw hard lines for that. Okay, same way as I was supposed to tell you this first, then I will be making the dotted line over here after. Okay, you don't have to draw the hard lines, you have to draw the dotted lines, because these are the imaginary lines which are we are going to draw. So this one is theta. We always know that in front of theta there is always our opposite side, and opposite side always make an angle of sine theta. And this one will be so, and this one is our adjacent side, so our adjacent side will be making an angle of cos theta. Okay, so identities over here will be cos, and over here it will be sine. Is it clear? So that is our vertical component, and that is our horizontal component. Okay, or opposite side and adjacent side, as you know, with it. That is our adjacent side. Is it clear? That's why I have drawn this figure into its rectangular components. I hope now you have cleared your concept about it. Look now, what are we going to do now? We are supposed to calculate theta. As you can see that this 15 is from ground to this. But here I have drawn an imaginary line, and which is starting from here to here. It means that this will be theta. I can calculate my theta because I know everything. I'm going to use Sokato, or some people have curly brown hair, through proper brushing. Okay. So what will be I doing? I'm going to choose Sokato, like sine theta is equal to, now let's move to the next question. Let's move to the next type of question. So in my this kind of question, in this type of question, okay, now whenever we are going to have an inclined plane, again we are going to make some rules. Because on inclined plane, our perspective will be different. Our perspective will be different. So we are supposed to draw three lines. First thing is that I'm going to draw my person P. As I told you that person P will always be at an angle of 90 degrees. Okay, so here is my person P. Okay, and upward force will be coming out from its head. That is going to be my upward force. Downward force will be over here, and let me draw clearly the downward force so that we should be having less ambiguity about it. Okay, that is my downward force. And there is one more force which will be acting on it, and that will be weight. As you know that weight always acts like this. Okay, weight always have to be acting downward, like towards the center of Earth. Now, we are going to make some rules for that. So what will be the rules? Rules for inclined plane. Rules for inclined plane. Rule number one, we will be drawing three lines. Okay, so first line will be drawn for the line of mass. First line, 1 minute. Whenever the object is on inclined plane, we will always draw three lines. Always draw three lines. First line will be line of weight. First line will be weight, which will be always at 90 degrees, 90 degrees to the ground, to the ground. Second line. Second line will be downward force. Second line will be always at 90 degrees to the surface. And third line will be parallel to the parallel. Three lines will be drawn whenever our object will be at inclined plane. Okay. Now let me introduce that. Which one is our first line? This is our first line, which is weight line. Okay, which is making an angle of 90 degrees. The ground. This is ground. Second line. This one is second line. Second line is at 90 degrees to the surface. Okay, and third line. Third line is gonna be the line which will be parallel to this surface. This surface. Okay, this line will be parallel to this surface. Because we know that our M1, because in M1, our person P does not know any other line except the up and down forces. Look, if I will be drawing here this as a weight, do you think that this person P is gonna know about this weight? It does not know this weight. It knows only this force downward according to its perspective. As we know that this is our weight W. So if this angle is theta, then this angle will be theta as well. Okay, which is 30. Okay, I'm gonna write 30 here. It is 30 as well. So in front of theta, it will be W sine 30. This will be W cos 30. Okay, so this is the way to choose our lines. Now let's move to next example like this. If we are having this kind of person, so what are we gonna do? We are gonna follow the same rule. First is that, because look, in this case, the contact point is this. Okay, we are assuming this, it is moving upward. The force is being applied and it is moving upward. It means that this will be our contact point. So I'm going to introduce my person P over here. Like at the angle of 90 degrees, my person is P is gonna stand. Okay, so here will be my person P. And if my person P is standing here, then this will be my, because we have discussed that according to rules from the head, it will be upward force. If this is upward force, then this will be downward force. This one will be my rightward force, and it will be my left force. Is it clear? Now, there is one more force which is acting on that ring. That is weight. Okay. Weight is always also acting on this. So it means that weight of the object will be downward. This will be my weight line. Is it clear? So that will be my weight. So it means that in this case, look, you can see that now weight, like as we have discussed that weight is always the downward force. Here, weight is the leftward force. Weight is not a downward force. Okay. Here, weight is a leftward force. So, I told you before that you have to consider a person P. You have to change your perspective. You don't have to consider your perspective. You have to consider the perspective of person P. If person P, and there is one more thing. Let's revise the rule for person P. Person P will always be standing at the contact point, okay, and it will always be making at the angle of 90 degree with the surface. This is a surface, so it is making an angle of 90 degree. And third thing is that the upward force will always be coming outward from its head, and that is that. And the remaining forces will be chosen accordingly. Is it clear? Now let's move to next question. Now let's move to the next part and see where our person can be standing over here now. Okay, now according to this part, let's draw our person P and see the shapes. Okay, this is my contact point. It means that at the angle of 90 degree, my person P is gonna stand. My person P is gonna stand in this condition. One more thing, upward force. Now, upward force is going to come out from its head, and downward force will be in this direction, downward force. And it will be upward. This will be my right force, and this will be my left force. Let's draw our person P at the contact point and at 90 degrees. So this is my contact point and 90 degrees. So here, this is my upward force. This will be my downward force. This will be my right. Okay. And same way, we are going to resolve this into its rectangle components. This will be 0.195 sine 0.195 cos of theta. I hope you have cleared your concept till that.